What that was, Hank, was summited Denali in Alaska.
Okay.
Well, actually, I'm going to show one thumbnail here first. I'm going to go back a second. This is a study that we did that was done with the University of Wisconsin and the Milwaukee Riverkeeper and the Milwaukee Metropolitan Sewage District. So this is a summation of about 178-page study. And then I'm going to move that away so you can't see it. So anyway, we wanted to see what would happen if we had beavers re-established across this watershed. So to get this to move forward, let's go to there. Okay. So that, as I mentioned, Milwaukee Metropolitan Sewage District, the University of Wisconsin, and really what we did a modeling of the river to see what the potential flood mitigation benefits for beaver-created wetlands to restore the natural hydrology and reduce flooding during high water events. So this is green infrastructure at its best, in my opinion. So if we look back to pre-settlement, Milwaukee is on the western side of Lake Michigan. This is a 1775 map, but by 1730, beavers were somewhat extirpated from here. Most people don't realize that beavers were generally extirpated about 100 years before settlement happened in many places. So, and the reason for that was really this heavy trade. Europe wanted hats and they used the fur from that and matted it. But we have a Stone Age meeting a semi-industrial age. And with that, iron, stone goods, fabrics, things like that were highly valued. So this was a mechanism, and it was the only currency that happened at the back. So this was, some people have called this the dewatering of America, but it also was the de-beavering. And each of these streams held, all the streams in North America, other than down in Florida and a few parts of desert, had amazing numbers of beavers. So this is the rodent, and it builds these dams and it builds the structures, and it has this iron oxide in its teeth, which you can see here. And basically they're 100% herbivore, and they can get the sugars and carbohydrates from the Cambrian of bark. But most of what they eat is actually aquatic plants. But what's different is that they build these structures within watersheds. So they'll have a den, and then they'll build a dam to create a pond, and then they'll also have canals where they'll cut into various areas or connect oxbows for forage. And they're known as an ecosystem engineer because they completely changed the hydrology. So in pre-settlement, what you had was a series of ponds like this. So this is a map from a book by Henry Morgan that was published in 1868 called The American Beaver and His Works. And it's up northern Michigan. And this is what you had at that time. So these dams actually are interesting because I've flown over them, and here's one of them right here. So I'm flying in a plane looking down, and this is what you have. So you have a series of structures. Here you've got, these are dams here, but these are also canals where they're going off to feed. So this wetland complex, when you were talking about, the question came up of like, how does these wetlands, or how do these things break down pollutants? These things work in twofold. They work somewhat like a stormwater detention pond, but they also work like a sewage treatment plant because of the biota in here and the complexity is involved, and you get a lot more breakdown. So what you have is, so beavers with rivers are stable, and you've got this biodiversity. So you have a series, think of it as a series of steps rather than just sort of a ramp. And Glennis Hood is a researcher in Canada, showed you get about up to 8 times as much water. But when you get this, you get this groundwater percolating back up, so you get filtration, purification, and you get upwelling, but you also get stability of the system so that peak flows are lower and base flows are higher. So you're getting basically stream health. But with that, you're also getting a tremendous amount of biodiversity. So this is an example. This picture was taken within minutes of each other. This is a different stream of a couple miles away, and this is what it looks like during a thaw in northern Wisconsin. And the water coming through here is relatively clear because of these structures that are in there. So it's a restructuring and it's a stabilization. This isn't that other same watershed that I was showing you a picture of earlier with the old map. So it's really a series of steps. And with that, all that series of steps, you get this amazing biodiversity. So we're in what's known as the sixth extinction. And this wetland complexes that were present across North America have birds, insects, aquatic plants, mammals, reptiles, and a tremendous amount of forage base in terms of wide variety of insects, which basically make them increasing the carrying capacity so that the number of species and the populations of those species will be greater. Same thing happens in areas where you have beaver systems intact, where you have, let's say, this suite of carnivores on the side. The territories are smaller because there's greater carrying capacity. So it's simple like that. If you're going to go to the grocery store, you might go to a grocery store that you know where stuff is, but you'll go to generally the closest grocery store unless you're, got some special foods that you need. So these territories shrink when you have a larger, more beavers in the population. And this is what they look like. This is a picture close to where we have a cabin in northern Michigan. So there's a lodge there and a lodge. And sometimes they'll use this one and sometimes they'll use this one. They seem to move them around. But this is what you're getting. You're getting this complexity and you get an open space in the forest. This is in Voyageurs National Park. And this is a good time. You count them in the fall because when they're active, they put a cache in. So you have a lodge here. Can't quite see it, but there's a bunch of brush that they stick down in the mud. And they'll do this in late fall and it becomes really winter food. So it's working like a refrigerator for fresh cut things. This is Voyageurs National Park. So this is about a 500 square mile area. And this has one of the highest densities of beaver in North America, but it's a new park. This is a recovery. So this is a national park that was started in 1976. So it's approaching maybe 50 years. And there's many people who used to trap this and get 150 beaver a year. But what you have is a new structure going. So they can recover quickly if they are protected. So they have a great symbiosis with a lot of other species. So within that map I just showed you, there's about 31 great blue heron rookeries in there. Mm-hmm. Every one of them is in a beaver dam. And you get a higher grade of connectivity with that. So you also have ospreys in there. So this mechanism of having these beaver structures creates the habitat for that, but it also spins off for a lot of other species. This is from a study from Steve Wendells, who's one of the biologists in Voyageurs National Park. So what you have here, and all these ponds can be all different kinds of size. So this is a beaver dam. This is Tom Gable. He's a wolf researcher. You can see how he's about 6 feet tall. And that's the dam there. And this particular pond is probably about a square mile in terms of its lake. That green in the background is actually an island. But then you get all the other species that come with that because of what they create. They can also be, this is only 15 feet across, and this is about a 5-acre pond here. And they'll often take advantages of 2 bridges or 2 ridges that come down at a narrows, and they'll block that off. This is a large beaver complex in northern Wisconsin that is probably over 100 years old, and it has hundreds of tons of material, and it's about a quarter mile across here. But we have climate change going on, and we have a lot of stresses on the planet. So what that means is that we're going to be needing to, with climate, we're getting these big fires out in California. This is a beaver complex in Idaho that basically became a refugia during this big fire that happened. This was a couple of years ago. And in California, the fires that were burning like crazy last summer. And the cost of this to us as a culture and the United States and the planet is extremely high. So in the Midwest, upper Midwest, one area I'm focusing here is in the Western Great Lakes. So this would be Minnesota, Wisconsin, Michigan, and Northern Illinois also. We're getting what's called a cell storm. So we're getting these storms with a huge amount of energy, a lot of rain, and sometimes a fairly short pocket, meaning let's say 50 square miles and you're getting 10 inches of rain. And so what that happens is you get this happens to be Richland Center, Wisconsin, a few years back, where they had a 7-inch rain followed by a 5-inch rain about 2 days later, flooded the town. When this happens, it wrecks everything. And this is a storm that happened in 2016. This is a federal highway, Highway 2 up in northern Wisconsin. So this normally has a 300 cubic feet per second river. and it went to 40,000. And this is a river that was very much de-beavered by poor management by the Wisconsin DNR. This is a picture of Houston when they had the hurricane a few years ago. So this instability is manifesting in a lot of different ways. So this study that we did is what I'm going to go through it rather quickly, but I want you to, I'm going to not go into the weeds of the crunching in numbers, but I'm going to overview it. So Milwaukee Riverkeeper is an organization that's dedicated, it's an 501c3, and its mission is to really work towards water quality and wildlife habitat in the river corridor in a 3-river system. So this system's about 900 square miles in scale. And we used a model called a BRAT, which is a beaver restoration analog tool, which he's from Utah. And we used that to identify habitat that is good for beavers. So basically, what we ended up doing, we ended up locating about 52 locations where we could have beavers, even though they're extirpated in this area now. And then we did these computer models where we ran different lengths of different kinds of storms, rain events for 5 years, 10 years, 25 years. And there are 3 height elevations of these dams that we hypothetically put in these locations, either half a meter, a meter, or a meter and a half. So this is some of the hard science where you look into soils, infiltration, percolation, soil profile, what's the gradient from here to here. So Milwaukee's down here, and this is the watershed, and we have Lakes Michigan on this eastern side. So we have some known hydrology because there's a number of gauges in here that let us know things. And we have a matchup with meteorological data to know what happened at that time. So what was the gauge? What's the normal gauge? And if you get a 5-inch rain, what happens at that point? So this is some of the background data for what you need to do to run these models. And then we use GIS because we could look at pre-settlement maps, and we could also then, we use a collector. So we took your phone and we basically designed what's called an ArcGIS collector, which would let us go out, and we went to about 160 places. And then that happens to be, we take a picture, that's a beaver lodge right there. And then we'd see where there's cuttings here. And then we could note the quality of each of those places. And we gave it a scale from 1 to 5. Is it good or poor? And then we broke down the river into all the different branches of it, which is number. And then in those sub-basins, so you take one of the sub-basins and you divide it. So these are like cells within a river. So these are little sub-watersheds within the watershed, and this is a sub-basin within the larger system. But each of those has, we know what the acreage is, we know what the wetland acreage is, we know what percentage that is. But if you see here, you have some high percentages of wetlands. So we had in total, out of a 900 square mile watershed, we had 140 square miles of wetland, but it didn't have any beavers in it. So if we looked at some of the best prime sites and we put these hypothetical model in, and then ultimately we selected 12 sites where you would have ideal beaver restoration happen. So you'd be reseeding, if you will, the area to have them have a natal area, and they would spread out. So this would be a typically good one. So this is a place called Cedarburg Bog, which is a natural area. This is about 3,000 acres, this green blob here. And this is one of the locations. So, but then what's the results after you do this and you're looking into the past? What are you going to see after you get things done? So some people would say we came up with a carrying capacity of about 4,500 beaver. And so 840 colonies, but you'd only, if you think of that, it sounded like, well, there's no beavers and now. So you have to, there's sort of an ecological amnesia with almost all the agencies of America. You can't imagine what it might have been look like to be here in 1700 and see passenger pigeons literally darken the sky, or to see watch buffalo go by in mass. We had millions upon millions of beavers in this country, and it changed our hydrology. They are the ultimate in green infrastructure to restore the stabilization of our rivers and also give us water quality benefit and address the biodiversity crisis. So we know we're going to have more storms because we don't have any governance that's doing diddly-wit about changing the amount of fossil fuel that's being emitted. We're lowering it a little bit, but it isn't enough. We have about a decade, a lot of the experts in climate, that we need to respond to. So some people would say, well, that can't be possible that you could have 4,500 beavers. There's not one there now. Well, that really just means one colony for every 100 acres of wetlands. And if you know much about wetlands, you know that that's actually a pretty good size marsh. So we've been trying to push against our Wisconsin Department of Natural Resources, which has their head in a very dark place, the lower part of their anatomy, about this, and to get them to change. So what happens when you put one of these dams in one of these locations? So this, on this map, you see a spot here. So we put a dam in, and this is the dam right there. And even though it might only be a meter high, we end up with a 62-acre pond. So we have a very shallow basin here. And this is how it changes the stage levels for flooding. So we ran this at 52 different locations, and then ran the model variance. So this is what this image here is what the pond shape would be like. Here it's this one. This is the location. And so we know that this would be an area, and the Milwaukee Metropolitan Sewage District is unique in that it has a program where it wants to buy 10 to 15,000 acres of land and has the money to do so. So this would be where we might be purchasing this wetland complex in entirety, and then Beavers could really change the hydrograph. So here's a hydrograph. So you get it. This is without Beavers, and this is with Beavers. So you're getting a change in discharge at this particular spot on these creeks. So there's several branches. One's east, west, north, Cedar Creek, Menominee, South Branch. But you look at these differences of discharge, this is cubic meters, and you're at, let's say, 270 there versus 400. Here you're at, let's say, 60 versus 100. So you're getting significant lowering of peak flood levels. It's the same amount of water, but it's also, because of the beaver structure, it's getting pushed down into the water column or into the groundwater, and it's resurfacing cleaner. So this is 3 communities. So here we've got about 2.25, 400. You can see the differences. So it really does, it flattens the curve significantly. And these are different communities, and that's this thing combined together. So this is this different stages of different types of flooding or different levels of storm that you have. But it's interesting, once you get a big storm and the system gets filled up, these beaver structures make us, and basically they're just wetlands that have water in them. So the average flood peak for the whole system, and this ends up being downtown in Milwaukee, was about lowered 37% for a 6-hour, 10-hour storm. And so at different stages, you had this variable rate of about 10% variety here. But we had other communities where it lowered it as much as 62%, which is West Bend, Wisconsin. So the simple takeaway is, when you have these peak flows with beaver dams, the streams are more stable and resilient. You get less phosphorus loading, because 40% to 50% of the phosphorus loading in the stream for an annual thing happens during a high water event. And so you're getting these, you're bumping that down. This is your base flow. It's higher after. So, but you're also getting a similar effect with the thermocline. So it's warmer in winter and cooler in the summer. So, if you're going to fill the watershed with biodiversity, the simplest way to do it is beavers, and you get the flood benefit. So one of the things that came up was, so what's the metric value of this? So what's an ecosystem, ecosystem services, and people throw numbers around. So the Milwaukee Metropolitan District, so we took these various locations here and we put these various dams in at ponds. So this is the pond area. This is the length of the dam, let's say, that could be at that spot. This is in feet. And this is not unusual to have 100 yards or a 300-foot dam. And then what's the acre feet in half volume or full volume? So the metric that MMSD has is $1.95 a gallon. In other words, they're paying developers $1.95 to have built storm detention plans, and then they're paying 50% of the value of that, because they have a fairly aggressive program and a fairly progressive program at looking at using stormwater and flattening this curve, because at the end of the pipe is this downtown city of Milwaukee, which is the major economic engine and capital of the state of Wisconsin. So the storage acre feet that we could get would be about 5,000. So at 1.7 billion gallons at half storage, but with the program with full storage, this ecosystem, if we re-beaver this and had those 52 dams in place, MMSD would value that at $3 billion, which is kind of amazing. So I've told them I can do this for 1,000th of this. So if you'll give me $30 million, we can build this for you. So this is a little mantra here. Let's get building for MMSD. And this is what downtown, we did a computer simulation also if we had a big storm and what downtown Milwaukee might look like if we have one of these major cell storms. Now, these are going to continue to happen as long as we have instability in the planet for climate. And so it could be your city, but this would work really across most of North America. I know some of you are down south and some of you east, west, but what most people fail to realize is the unbelievable potential this rodent has to save our butt during climate change. Mm-hmm. So Steve Wendells, who's this biologist, who's a colleague of mine, this is his line. So, and so I went through this very quickly, but I thought I'd leave some time for the chat. So here we go. I can stop the share now and we can see each other.
Well, I predicted that this would be a fascinating presentation, and you lived up to the prediction. Thank you. Do we have questions?
Yeah, there's one question from Doris. And she asks, where do you get the beavers from for the projects?
Well, we have a small remnant population in Milwaukee County, because in that county, and also it goes up to Ozaukee County, which is the county north of there. And these are fragile, genetically, they're extremely valuable. So in many cases, there's a project out west, the Methow project in eastern Washington, where they basically are live trapping beavers in certain places where people will not tolerate them. And then they have a fish hatchery that they have use of, and they sex them. They put a boy and a girl together, and they put them in these raceways and have a little hut for them. And if they like each other, they call it a couple, and then they take those two and then they put them in various locations. So getting beavers, there's a lot of areas that are don't recognize the ecosystem value of them, and they can cause nuisance flooding. How you can handle nuisance flooding, though, is you have basically someone on staff who is basically installs landscape plumbing. So there's flow devices that allow you to control flooding on dams. So it's a big stack pipe like a culvert that goes right through the dam. And at the other side of the dam in the pond, it has an elevation. So if the pond gets too high, it goes into the pipe and it goes through, and beavers can't figure it out. So there's a way to manage them and coexist with them. But if she wants to email me, there's an online service. There's a thing called the Beaver Institute, and they have full-time jobs and trainings in how to do this landscape plumbing that I referred to.
Great, thank you. And then Mike asks a question, a very general question. How do we re-beaver?
We re-beaver by allowing them to live. And in many cases, they're somewhat extirpated, but in many cases, there's a very small thing. So the easiest way to do it is to provide forage in locations where there would be good. And also, if they're going to create a pond, you either purchase the land or you rent the land, or you have some sort of like a conservation reserve program, which is an incentivized to farmers. So if you could pay farmers to say, well, let them flood your bottom land there, and I'll pay you for that as long as there's beavers there. The other thing that if you wanted dams, so one of the things that we would do is we actually want a lot of dams for this stabilization of the system. So part of the program would be actually planting aspens. Because we can figure out with GIS exactly what would be a good spot for it, because, like a 1 meter dam and you get a 60-acre pond. So if we plant an aspen grove on either side of that, we can, in essence, give them the building materials and the food and the incentive. And if you have beavers there having some supplemental feeding. You want the girls going into winter nice and plump and happy and, receptive and in good condition to breed and have kits. And with that, you get, and then they'll disperse. So they live in the family unit for about 2 years. And then the boys and girls, mom says it's time to go out and get a job, and off they go. And they will recolonate. And they'll basically often go upstream and create new areas that were sort of what I call dormant wetlands, and then block it up. This is where they can get into trouble. And so you need to have that. So most of the, like in northern Wisconsin or Minnesota, there's a lot of wolves, and wolves can eat a lot of beavers. In other places around the country, there's coyotes, and they'll feed on them too. But beavers are they're fairly intelligent, and they do pretty well. I hope I answered your question. You take the science of reestablishing beavers, and there's whole manuals on how to do that, and you open the book, read the directions, and start going.
Bob, you indicated that your adversary here is the Wisconsin Natural Resources Department, or
correct,
a state agency that is apparently determined to make sure that beavers don't build dams. Is the Wisconsin Department of Conservation or Natural Resources Agency, I assume that they are typical of the same agency in every state, that all states have the same attitude officially. We need to keep the beavers from damming up our creeks. Is there anywhere where government at the state or local level gets it?
Yeah, I'd say Oregon is fairly progressive, and Massachusetts are two states that are very progressive. Canada manages beavers very differently. They manage it like a concession. So you would have a pretty good area. You might have 200-300 square miles, and you're the trapper for that, and you want it to be sustainable. Wisconsin's season for beavers is 5 months long. Any method of take is allowed. No limit, no recording. So you have no way of managing something if you don't know what it is, and two, you have open season on it 5 years a month. The best thing going on right now is that fur prices are very low. So if you get a prime large beaver that can be up to 60 pounds, and you go out and you trap it and you drag it home, and then you skin it out and you treat that fur, which there's a skill to handling fur, and then you take it to an auction, you might get $10. So you've just invested probably 4 or 5 hours of skilled work to get $10. So that's one of the biggest positives of them. And it's right currently, but there is a Minnesota, it really depends on, so you could have trapping for beavers if it was done in a sustainable way. But the way it's done now, it isn't. And, when prices for fur were high, for example, guys would use snow machines, and they'd use ice augers, and they would put 8 holes right around a beaver lodge, drop in 8 conibear traps, and everybody be killed. And you, in essence, erase that whole functional aspect of the hydrology of that landscape. You've just extinguished it. So they need to be protected. Where I've been proposing to somewhat deaf ears that we have a ban on aquatic mammal trapping in this watershed to allow it restore. The economic value of $3 billion. There's also some Clean Water Act. So within Wisconsin, I won't go into detail of how idiotic they are, but anyway, we'll keep moving here.
And I don't want to monopolize, but is your riverkeeper, is that connected to the National Riverkeeper?
Yeah, it's a Waterkeeper Alliance, which has, so I had founded it about 1995. And then, so I haven't really, and I'm sort of the emeritus, founder and executive director of that, but I have really not been too involved with it. I've been doing other sorts of environmental work, and I brought this back to them as a project and wrote the grant, and then got And the interesting thing, Milwaukee Metropolitan Sewage District, who paid for this, they're the first person I sued for violations of the Clean Water Act about 2000, and they had to spend about $100 million in infrastructure increase. So I have a good relationship with the guy who runs it too. So it's all ironic.
What I'm trying to get to is, so your position is the policy, Waterkeeper Alliance.
Oh, no, I wouldn't say that. I'm interested in the, not all, no, the Waterkeeper Alliances run independently. They don't have it as a national policy. It would be good if they did. I haven't actually made attempts to, shake that tree and get that to happen.
Okay, all right.
Where are you located, Hank?
I'm in Kentucky, and so I'm curious about Kentucky's beaver potential, but
it's huge, actually. And, throughout your states, you've got those valleys and rivers. It really would stabilize a lot of your hill country tremendously.
I'm thinking. Somebody else's turn.
It looks like Anne has her hand up. Go ahead, Anne.
Yeah, I live in the Western Catskills, and there are a couple of towns that have really serious flooding issues. I mean, their floodplains are pretty big, and actually, ironically, the one town I'm thinking of is along the Beaver Kill, and I'm just wondering if how does that work? I mean, if I know people in the town, if I went to suggest beavers, how would I just put people, would that be a possible solution to their flooding issues, or how does that work?
Well, you'd want to analyze your system in terms of, I don't know what your state law, are you in the Catskills? You're in New York State?
Yeah.
Okay. So there's a beavers and wetlands in the Western Adirondacks would be a good person. So it's Sharon and Owen Brown, and it's beavers and wetlands. I would contact them because they will know any resources that you would have within New York State for beaver introduction. And it's interesting that the Beaver Kill, the name of it, maybe that's why it's flooding.
No, kill is the old Dutch word for river.
Okay, all right.
New York was Dutch originally, so.
Yeah. So I would, every place has its own set of DNR's paradigm and how you can get change of law. But this study, I can have that, I can make this available or send it to you as a PDF. It's really written in way, the study, I'm giving you sort of the results of it. There's a lot of hydrology in here, a lot of number crunching, a lot of engineering.
Right.
But the bottom line, mostly I was interested in this because I'm interested in biodiversity and water quality. And my client is interested in flood relief. So, but we get the same thing from the beaver.
Right.
So thanks, Hank, for your work today.